All right, so this is part 2 of the naming and formula writing lesson with polyatomic ions. So yesterday, what we learned how to do, or in the previous part, I should say, is what we learned about was how polyatomic ions are these molecules that have charges, and that we can illustrate these molecules the same way we would any others, as combinations of atoms. And to illustrate their charge, it would be simplest to just simply assign the charge to the molecule with a circle, or even something like a dotted circle. So we're going to use that skill today to write names for ionic compounds. So the steps to writing the name for an ionic compound is the same as it's always been. That first element, or the cation's name, should go first. Now, since we're not referring to single monoatomic ions, we're going to have to consider the fact that we might not be looking at an element. We might have to look for a group of elements that matches something on our list. Like NH4, I can recognize as a polyatomic cation because I've been very familiar with polyatomic ions. You might need some practice before that becomes something you recognize. But NH4, if I recognize it as a cation, is the first ion in the compound. So its name should be first in the compound's name. Now NH4 on that list is named ammonium. Now, when I'm naming ionic compounds, I don't need to change any part of the first element or cation's name. No prefixes are required. It's just a simple writing down the name from that list or the periodic table. So now that I've named my cation, my next rule comes into play. The anion or the negative ion, whatever comes second in the formula, should be named second in the name. So CO3 is my anion, so I need to find CO3 on my list of ions. Now, again, helpful hint, all of your anions or your negative ions are going to be on the right side of this list, and all of your positive ions or your cations are going to be on the left side. So knowing that I'm looking for an anion kind of helps narrow my focus so that I look on this right side. Now I'm looking for CO3, the formula CO3. And what I'm going to find is I'm not going to find perfectly just CO3. I'm going to find CO3 with this -2 charge, and that's okay. The -2 charge is just indicating what CO3's charge is. So carbonate is the name for this ion, CO3. So in my name for my compound, I'm going to name CO3 carbonate. Now, what we've done in the past is we've changed the ending of that second element to IDE. We don't need to do this when we're working with a polyatomic ion. So let's practice using these two rules with another example. So NiCrO4. So it looks like I've only got 3 elements. So the trick is figuring out what is my cation. Now, as you grow familiar with your ions list, this is going to become a little bit easier and easier. But until that happens, it might take some trial and error. Ni, I can tell, is not part of any polyatomic ions, which tells me that Ni must be the first element in my compound. It must be the cation. Now, if I look on my list, I can see that Ni, nickel, is actually one of my transition metals, which means it's going to require a Roman numeral. So when I write nickel's name, I'm going to leave some space for Roman numerals so that I can figure out what that Roman numeral is at the end of this problem. Now I can focus my attention on the anion. So CrO4 must be a polyatomic anion. So I'm going to look for it on my list. And since it's an anion, I know it's on the right side. So CrO4, the formula is right here. The name that corresponds to that is chromate. So since this is polyatomic, I don't need to change any of my endings. And I can just leave this name chromate. Now, time to figure out what is this Roman numeral. The way that I'm going to do this is by balancing my charges. So I need to figure out what is nickel's charge to balance out this chromate. Now, when I look at the lists for chromate, what I'll find is that chromate's charge is -2, which means that nickel's charge must be +2 to balance it out. So my Roman numeral should be the Roman numeral 2. Interesting. There we go. Let's try this again. Pencil is not wanting to work. There we go. So my complete name would be nickel 2 chromate. So let's try one more example together, and then there's a few tries. So SnC2O4 in parentheses with a 2. When I'm looking at this name, the first thing I want to do is figure out what is my cation. So Sn appears to be that first element not bonded to anything else, which tells me it's my cation. So when I look at my list, Sn is actually one of my transition metals, which means it could be tin 2 or tin 4. It could have a Roman numeral there. So let's go back. And when I write this name, I'm going to leave some space for Roman numeral to figure that out later. Now I can focus my attention on the anion. So C2O4 is really the formula I need to worry about. I don't care that there's 2 of them. I don't care if there's 3 of them. It doesn't matter how many C2O4s there are. It just matters that I figure out what the name is for C2O4. So when I look at my list, C2O4 is right here, and its name is a little funky. It's pronounced oxalate. So C2O4 is oxalate. Now that I've figured that out, I can focus my attention on figuring out what should this Roman numeral be. So I don't know what tin's charge is, but I know that C2O4, each of them I should say, has a 2- charge. So C2O4 is 2 negative, and there are 2 of them. So what that means is that tin has to have a +4 charge. So my Roman numeral for tin should be the Roman numeral for 4, IV. Go ahead and pause the video and try the next ones, and you can check your answer when you're done. I'm going to assume that if you've unpaused, you're ready to check your answers. For the sake of time for this video, I'm just going to write the answers so you can get that immediate feedback. The first try should have been iron sulfite, iron 2 sulfite. The second try should have been beryllium hydroxide. No Roman numeral required as it's not a transition metal. And the last one should have been gold 3 phosphate. So now that we have this skill of writing the name, let's practice writing the formulas. So this should be the back side of your notes sheet. So when we're writing the formulas, the steps are actually the same as they've always been. Find the charge of each ion, balance those charges, and use subscripts. So let's practice. So this first example, lithium carbonate. Lithium is in my group 1, which means it's got a +1 charge. So step 1, identify lithium's charge. Carbonate, I'm going to have to find on my polyatomic list. It is not going to be on the periodic table. So when I find carbonate, I see that its formula is CO3 with a 2 negative charge. So +1 and -2 do not balance out. I need 2 lithiums to balance out this charge. So when I write my formula, I'll need to indicate that 2 lithiums balance out 1 carbonate. Let's try another example, but this time we can be a little bit more thorough in how we illustrate this. Some students really like the formulas, some students are a bit more visual. And oftentimes I'll ask you to illustrate these visuals. So ammonium sulfate, both of these are polyatomic, so I'm going to have to find them on my polyatomic list. Ammonium is NH4 with a +1 charge. So if I wanted to illustrate this visually, I could draw a nitrogen connected to 4 hydrogens. And this whole thing has a +1 charge. Now sulfate, I'm going to have to find on my list. Oops. Sulfate is SO4 with a -2 charge. So if I were to illustrate sulfate, it's 1 sulfur connected to 4 oxygens that overall has a -2 charge. Now I can see that +1 and -2 don't balance. In fact, I'm going to need 2 ammoniums that each have a +1 charge to balance out that sulfate. So when I write my formula, I need to indicate that there's not just one NH4 ion, there are 2 of them. The way that I do this is by putting NH4 in parentheses with a subscript of 2. And since there's only 1 sulfate, I just need to write SO4 1 time. So let's do one more together and then you'll get to try some. Whether you like the more visual method or you like the formulas is up to you. I think I'll do this last one visually. It's not really a lot to draw. So copper 1 is an element. It's copper with a +1 charge. Bicarbonate, however, is polyatomic. When I find bicarbonate on this list, it's actually named in parentheses because this ion also goes by the name hydrogen carbonate. The formula I'm working with is HCO3 with a -1 charge. So when I draw this, I'm going to draw a hydrogen connected to a carbon and 3 oxygens. And all together, this has a -1 charge. Now looking at these charges, they balance. So my formula is simple. Copper and hydrogen carbonate, aka bicarbonate. Go ahead and try the next 2. Pause the video, and when you're ready to check your answer, you can unpause. All right, I'm assuming you're ready to check your answer. So I'm going to go through these with the shorthand way with just the formulas. Aluminum has a 3 positive charge. Chlorate is ClO3 with a 1- charge. So I'm going to end up needing 3 chlorates to balance out this 1 aluminum. So when I write my formula, it's going to be aluminum with chlorate in parentheses, and there will be 3 chlorates. All right, last but not least, calcium nitrate. So calcium has a 2 positive charge. Nitrate is nitrogen connected to 3 oxygens. And altogether, this ion has a -1 charge. So I'm going to need not 1, but 2 nitrates to balance out this 1 calcium. So when I write my formula, there will be 1 calcium. However, I'll need to put nitrate in parentheses with a subscript of 2, since there are 2 of them. So now that you've completed these tries and this part of the lesson, you are ready to move on to worksheet 2.